Alright, time for another DraftScience video presentation. I think kind of an overview video. So an overview of the conversation first. So there's really no counter arguments in any kind of, scientific form. So I've made 3 videos on the 3 major subjects: gravity, photons, and energy. And there really hasn't been anything like a coherent counter argument to anything stated in those videos. Just isn't. You are open to email me. I have an email address is provided. And yes, you can be as rude as you like and all that stuff, but obviously I'm not going to, respond to any of the rude parts. I don't have an obligation. See, it seems that some of these people who disagree with me, they can't form their argument in anything but a bunch of lies and, mischaracterizations and distortions, and I don't really have an obligation to keep defending myself against lies, and so I'm just not going to do that. So if they can't make an argument without lying as a premise, I'm not going to read their argument anyway. I'm not going to respond to it, and I'm not going to reward it. But if they want to email it, then I can just say, yeah, I didn't get anything. All I got was a bunch of lies. I didn't get a real argument anywhere. So I'm just saying I've given them the opportunity to make their argument. Give me the link to the professor you think is doing physics right. Show me this great physics you have. Show me your evidence. And they won't do it. It's just a simple argument. I mean, I'm asking them to show me the evidence, and what are they showing? Nothing. They're just making a bunch of bizarrely stupid and irrelevant accusations. But anyway, so, that's the status of the argument. I'm offering $2,000 to a channel with that gets substantial viewership, something in the thousands of views per video. I will include channels that have less than 100,000 subscribers if they are, more relevant. And all they have to do is play one of those 15-minute videos, average 15, let's say, $2,000 on their, for playing a video and allowing the conversation to be more broadly had, to a wider audience, just to see if we can solicit these better arguments, because so far the arguments are horrible. They're just horrible arguments. I mean, they're not making any arguments in defense of this bad physics. So I'll go through this simple, so that's the status of things. As it is now, I can't argue the argument that hasn't been provided. And one hasn't been provided. It's clear they can't really, there's no excuses that they can't get their argument heard. Send the email and then try to make the accusation I didn't respond to some good argument you made, because you can't. You won't be able to prove that. Okay, because yes, I am willing to listen to a decent scientifically presented argument, but they're not capable of doing that. Alright, so anyway, so we'll just go over the simple truth, as I would argue, the thing that makes the most default sense in terms of, how we should be perceiving the universe with certain axioms. So we're just saying we're detectives, okay? We're not prosecutors. We're not looking to make a name for ourselves, and we're not trying to be law and order, and we're not trying to do any of that stuff. We're just trying to find out the answer. Who did it? Okay, how they did it, that kind of thing. It's just detective work. So you have these different experiments that will provide you evidence, and of how the crime was done. You'll find footprints, you'll find fingerprints, you find this, you find that, and you try to figure this out. And so these are really tiny criminals. Okay, the universe is run. The small universe is the only universe. Okay, now that's an argument being made about a truth. Okay, that logically it doesn't make any sense to think of it any other way. That everything that happens, the electrons and the protons have to do it first. Not the atoms. No, the littlest bits do it first. So the smallest bits of matter have to be the origin of any action. And so the universe that's the most relevant is this very, very small universe. Nothing happens to galaxies or suns or Earths or any other object in the space, the empty space, until it happens on a subatomic level first. So that's a statement. I don't think there's any logical counter-argument of how it could work any other way. That there's some ESP force that doesn't affect electrons and protons but somehow moves atoms or moves planets or any of that stuff. No, it all has to be first elemental. And that the elemental bits are going to be simple, not complicated, because that's how evolution works. You start with something simple, and over time, it gets into complex patterns and arrangements. And so the elemental universe is going to be simpler. It's going to have simpler functions than the things that pop out of it. So you could argue that carbon and and oxygen and hydrogen and all these elements are kind of simple, but you can form them into a battleship, the more complex thing. But they're not battleships. They don't have a whole bunch of features. You can only have features and properties when you make things that are different and you combine the things that are different, the different arrangements. So it's another theory, another statement about reality, but that's how reality works. All right, I would argue the three-dimensional space thing is so obvious. There's three dimensions. There's three dimensions we're certainly in. We found out that space works the same way. It has three dimensions. Things are a certain distance away of empty space, and you have to travel the distance to get to the location. I mean, it's solid, rigid space, and the three dimensions have something in common. That is, the dimensions are all at right angles to each other. And so there's no other room. That's it. That's all there is. There's three dimensions, and there's no other spatial dimensions, and there's no room for a fourth dimension. There's no way to make a fourth dimension that's at right angles to the other three. So without violating the rule for what a dimension is, you can't have something else called a dimension. There's no fourth dimension. There's time isn't a dimension. Other things are not dimensions. There's three dimensions in space. Okay, now that's a statement. Now you might believe there's some wooey-verse or some other God thing or some other wacky crap that somehow makes it sensible to talk about. I really don't need to fix that. Other dimensions, but I don't see how it makes rational sense to say we need to extend this word dimension to include a bunch of things that technically can't be dimensions. So that's all I would argue. So I think it's a defendable argument that there's three dimensions of physical space, and space is nothing. Okay, space is a vacuum, and there's stuff in the vacuum. So that's all. And some of the stuff we could say is moving the speed of light, and then we could argue that all the stuff that we call forces, elemental forces, I mean not the force of your fist, but I mean the forces that are on the elemental level that move electrons and protons, all of those move the same speed, the speed of force. And so that's another argument to be made that yes, it would make sense to think in terms of a speed of force and not a speed of light. And that light is just like the other forces, except it's a little bit different. That's why we can distinguish it and call it light. So what there really is in the universe is just force and matter. So the matter, now we can talk about what's matter. And what seems to all the evidence points to is that inside of atoms there's two things, electrons and protons. They're in a shape, a geometry with each other, a connection to each other. Now there's a Bohr model, where they accepted 100 years ago that things are spinning inside the atom, and that's what's keeping it together. But you could also just make a magnetic model, where things are in positions, and like magnets, you can levitate magnets, just by putting them on a stick, and you can levitate them, and they'll stay in their positions. And so you can create a balance between magnetic fields and create a geometry that is durable. And so I've sort of explained that if, I guess I'll start drawing and such. Alright. So what I'm arguing what the evidence indicates clearly is that there are, the important part of matter, there's only really two things. There's the electron and the proton. And that's it. That's all there is. And it's just arrangements of electrons and protons that make an atom. So the simple atom might be, the nucleus will be a net positive because it has neutrons and protons in it. Now the protons are overtly positive, and the neutrons are really a positive charge and a negative charge. They're really an electron and a proton really close to each other. So you're really just saying the nucleus isn't all positive, it's just a net positive. It has 2 times the number of positive charges to negative charges. But it itself is a little system, a system of electrons providing a conduit that allows protons to get closer to each other. Now I've argued a simple mechanism for that is if you have 2 kinds of force and you recognize the inverse relationship between the charges, that is a simple argument that the positive force, so you have, let's just say that the argument is going to be is that this stuff force, okay, comes in 2 forms, electron force and proton force, in the sense that there's 2 kinds of reactions. That's why it's called 2 plus 2 plus 2 physics, is because there's 2 kinds of force, 2 kinds of matter, and 2 kinds of interactions. And the interactions are either to push something, all right, and so that would account for the fact that things are repulsive, is the fact that if the force bit gets between 2 electrons, an electron force, it will just bounce back and forth, back and forth, back and forth, back and forth, back and forth. The closer you bring the objects, the more impacts there are. So you can imagine it as 2 ping pong paddles, and you have a ball that never stops moving, always moves the same speed. And you could sort of understand that if you bring the paddles twice as close together, the ball will hit twice as many times, hit the paddles. So it's causing pushing energy on the paddles, and each hit of the paddle is the same. So if you double the number of hits, you've doubled the amount of energy. So you can simply double energy by just bringing 2 electrons twice as close to each other, because there'll be twice as many impacts with the little force bit, the ping pong ball, pushing the paddle. And that's all that happens here. It's a push universe. If something is attracting, it's because it's not repelling. If you stop pushing, you're basically pulling, because there's push on the other side. Everything's always got energy around it, and the fact is if you do something to stop the energy from getting somewhere, the little ping pong balls, it means the other ping pong balls are going to make sure it moves the other way. So everything relies on balance, and that's what's happening inside of the atom. So anyway, back to this argument. So this relies on the fact that the force just reflects off of electrons. Electron force reflects off of electrons, and proton force reflects off of protons, and it causes a momentum reaction. That is, the energy of the bit pushes the object until there's a counter force, like Newton said, to change that circumstance, and then the forces are reflected. The pushing force here and the pushing force here, they'll both reflect. All right, and the other interaction is if I take this electron force and I hit a proton, what's going to happen is that force is not going to go, it's not going to create any forward momentum, it's not going to push, and it's just going to be deflected, okay, perpendicular to its original motion. So you're just saying the force goes in this way and the force leaves this way. Now technically there's more to that, but I don't really want to get into that kind of conversation because it's all very speculative, but it's a simple principle. So you have 2 kinds of interaction. You can push something and move its location so the matter moves, or you can change the direction of the force. So those are the 2 possible reactions that take place in the universe. Electron force hits a proton, it gets deflected. Proton force hits an electron, it gets deflected. And if the same force hits, it moves the material object. Alright, so once we have that, so all we have is 2 kinds of matter and 2 kinds of force. And you can just, for many actions, you can understand that most of the elemental universe you would argue there's the same amount of plus as minus in the universe, so to speak. And so all of these interactions could be mute in a circumstance where you have an equal number of positives and negatives inside of something. So clearly atoms tend to go neutral. That is, the nucleus is not neutral in the sense there's twice as many protons as electrons, and then you add the exterior electrons to make it neutral again. And so some of the reactions won't be dependent on the pluses and the minuses and the fact that there's two interactions. All of that becomes blended into the fact that you're doing it with trillions and trillions of interactions, and so all of those, if they're all in different directions, will all turn out to look the same. All right, so the idea would be is this: the force is constant. That is, there's this force is flying through the universe from all directions, and at every location in space is essentially going to be saying, there's a certain amount of force that's going to interact with that piece. So there's forces going in all kinds of directions, but there's a specific profile of force that's going to hit you, or it's going to hit one of your atoms, or it's going to hit one of your electrons. So everything's just in a universe, a black universe of nothing, and there's just a fact that there's a certain amount of force that's going to interact with it, that's traveling billions of light years through the universe, and it's going to hit you. And that's just the way it is. So everything's under a pressure, an amount of energy coming in, and gravity just happens to be, well, here, that one's a good arrow. Leave that one there. The fact that there's a certain amount of pressure coming in from the universe, and the question is, do you produce the same amount going back out? So we know that you don't grow, you don't get bigger and bigger and bigger. We're not talking about biological growth, we just mean atomic growth. Your atoms don't grow, things don't grow, because the energy doesn't go in and stay in. It goes in and eventually leaves. It leaves in some other form. And the question is, does as much go in as leaves? And there you could see what gravity is simply put, there's more energy coming down on you than you produce back up again, or the Earth. So the Earth is a giant mass, and the fact is more energy is going in than is coming back out, and you're sitting here in that field, in the field where there's the stuff moving the speed of light. There's more of it coming down than is coming out, and the reason why is because inside the Earth there's a bunch of electrons and protons that are constantly being moved. They're constantly being pushed, and while they're being pushed, they're moving a bit slower than the speed of light. So the energy is essentially losing time, pushing matter, and it's not getting where it would be. So it should be shooting back up here to make this line equal, but it's not, because it's busy pushing matter at a slower speed. And that constantly has to be fueled. The heat inside the Earth has to constantly be fueled by new energy coming in to keep it all moving. Nothing moves perpetually except the force. The electrons and protons have to be constantly pushed. They have to constantly have a piece of energy next to them, pushing them. They have to collect it, so to speak. You could collect a cosmic ray, which would be a collection. Well, let's not get to that yet. So gravity can be explained merely as an inequity in the speed of the force. You're basically saying the force goes very fast when it's not pushing matter, and it goes kind of slow when it is, and that relationship means less is coming out than went in. And that pretty much explains gravity. Now, photons are relevant, but you don't need to worry about the inverse part here, because what people kind of realize is that photons aren't really bothering with the nucleus of an atom, but they are ionizing, hitting the electrons. So we could argue pretty simply that it's obviously electron force, because it's making electrons do things. And the simple argument is that just these force bits that are, generally speaking, random in the universe. They're coming at any, one hits, and then another one hits, and another one hits, and there's no built-in pattern. There's just a chaos of disorder. And what a photon is kind of it's an absence of that disorder, in the sense that something, like an electron, moved from this position to this position. And when the electron did that, what it did to the force around it, what it did to the force that was in the universe, is that it took stuff that was heading for this location and reflected it from this location. So like me moving my hand towards the camera, I'm essentially, if I move my hand at the speed of light, I would collect every piece of energy in the universe, every photon moving this way, every bit of energy, every little piece of force. I would be collecting it essentially on the surface of my hand, because my hand's going the same speed. The reflections are all just going to pile up on my hand, and my hand is going to represent I'm going to take arrows that were coming in this way, and at different staggered times, okay, and I'm going to basically turn them all into this. I'm going to turn them into a whole bunch of arrows at exactly the same place in time. So you're taking events that would happen at different times, and you're converting them into events that happen more at the same time. Now, photons aren't that explicitly. They aren't the collection of all the energy. They're just a thing where you're taking the energy that's in chaos, that is, it's randomly ordered, it's not in any specific pattern, and you're just basically saying, I'm going to put it in a pattern. I'm going to have a place where there is arrows, okay, and it might be a little bit out of alignment, and then a place where there's less arrows, okay, and then there's going to be more arrows in his place, and less arrows, and more arrows, and less arrows. So you're creating a frequency of the density of the force bits. So all it is really just thinking about, it's just these force bits with a pattern. Oops, shouldn't do that. With a frequency. So they're just this bits of momentum, and they have a specific period, amount of time between them. And a photon would be maybe 3 or 4 of those events. And what that enables the force to do is to break atoms, to damage them. So ionization energy is a key concept when talking about the photoelectric effect, or any effect that light can have, is that it really needs to be able to cause atoms to change substantially for it to be recognized. So you could argue that a regular atom could be hit by a piece of force. Its electron could move. These other electrons could therefore be pushed by the same energy. Okay, and there could be another atom next to it, which means that it's going to push in exactly the opposite direction, right? While this atom's pushing, this electron got pushed down, that's going to cause this electron in this position to push up. And you could sort of understand that the movement of those electrons is like the movement of this hand, and each time they move, they change the pattern that's in the field. They're changing when stuff reflects. Instead of reflecting from this position, the universe is going to reflect from this position. And the electron will go back and forth and back and forth. And as it's doing that, it's creating density changes in both of those directions. And the key to creating a photon, or manifesting one, is that eventually, to say you have enough energy to actually take one of these electrons and shoot it out. So you can understand that if you hit something and you cause some pressure between the atoms, and then you hit it again in another location, you're pushing these electrons, you're pushing this up, and then you hit that same piece of energy, and that is in the same location, you push down again, that's going to increase the speed. And you're just adding energy to the force that's already moving through the atoms. You're just going to hit, and then wait for the energy to move, and then you're going to hit again to make the energy go faster, and then you're going to hit again and make it go faster. So you're just pumping energy into a system. Now this gets into resonance and how you add energy to systems. And you add energy to systems by avoiding banging into the reflections that might be caused. So if you want to add energy to a system, and you have ping pong ball bouncing between two surfaces, and it has a pattern that it's bouncing at. The idea is that you need, if you're going to add more energy to that system, you need to throw your ping pong ball in while the energy is going in the same direction. So what you don't want to do is throw your energy in when the energy from the system is in the opposite direction, because if you do that, you can't add the energy. So you want these reflections to all match, in the sense that you want them all to arrive at a surface, whether it's coming from here, or it's coming from here, or it's coming from here. There'll always be harmonics, okay, that end up doing what they're doing at the same time on the surface, and therefore cause the surface to have more momentum in a direction. So if you want to add energy to a system, you have to add it at a specific period of time, and that's what makes photons make sense as important actors in what happens in the universe, is because what the frequency is will decide for different atoms what the tension is, the wobble in the atoms as they exist. And you're going to add energy. You want energy to go in this direction, then you have to add it at the right cycle, at the right period of time, for you to be able to add energy to the system, rather than have the electron moving back this way. So you don't want to crash into something when it's going against the motion. You want to crash into it when it's going with your motion. And that way you can add energy to a system and cause an electron to pop out of an atom. So that's why frequency is important. So it's just pieces of momentum that move electrons, and they're at a period. Now they're also at polarization, which means they're in a little different place in space in there. So they're all moving parallel to each other and from a different location, and that just makes sense, because you've got to figure that a surface of atoms created the photon by electricity traveling through a wire, for example, and it had to fire the bits at different locations and at different times. So obviously the period would be when they're firing, the period of the frequency, and the polarization would be the fact that they're firing from different locations. And so that's why you have, that's essentially, the atoms are the antenna, and it takes time for the electricity to go up the antenna, so therefore you fire your bits, okay, from different locations, but at the same period. Same amount of time between them, but from different locations. So it's just like firing a gun from, by raising or lowering your hand. That's essentially what a photon is. It's bullets in space that have two kinds of frequency. A frequency in this dimension and a frequency in this dimension. All right. So one we call polarization, the other we call frequency, or wavelength. So gravity is being caused just by the fact that there's energy in the universe, and a little bit of it gets consumed pushing electrons and protons. Photons are pushing electrons, okay, on the surface of atoms, and they're causing ionization. They're causing electrons to be booted out or to be moved from one place to another place, causing disorder in the atomic structure, causing charge, essentially. Causing there to be an imbalance in the atomic structure. Either it has too many electrons or it has too few. To be, strictly speaking, balanced in its number. And so it can have an effect on the chemistry or the configuration of the atoms. Whether the atoms are bound to each other depends on how much energy there is and how many electrons there are. You shove more electrons in, you make the bonds between the atoms weaker and weaker. That kind of syndrome. All right, and then the other phenomenon would be magnetism, which is just, now you're going to segregate this force, not by, you're not going to put it in a pattern, but you're going to take it and you're basically going to say that the force bits come in, and they're of these two style. I guess I could do a dotted line. I don't know, something to represent the two types. I'll just do a squiggly. Okay, so a squiggly line we'll just say is the electron force, and the straight line is the proton force. And so that stuff's flying through the universe all the time. And what a magnetic material is essentially doing is it taking that mixed force and it's saying, I'm going to send, all of the proton force, or a substantial amount of it, out in one direction, and the squiggly stuff out in the other direction. Now what's really happening, that's the simple way to describe it as filter. but the filter, just like light, it is not a pure filter. Okay, it's not just like light isn't all the just as I can't push all of the energy into one location, I'm just making it more dense. Magnets are doing a similar thing. So what they're really doing is making a pattern out of the magnetism, and there'll be two opposite patterns. Okay, the patterns are, it gets a little complicated, but you're talking about when things moving through space is like if I shoot stuff in all directions from one location, it goes out as a cone. And what magnetism is there's a cone that has either a center that's plus or a center that's minus, and then the ripples. And you could sort of understand that the two can't mix. If I mix, if I send two cones out that are both centered as red, then they're going to be repelling, because the red will repel the red. And there need to be an opposite for them not to have an opposite effect on the other object. So basically, the argument is it's still a segregation argument, and all you're really saying is that the two sides are creating an inverse pattern. So where this side is going to create, a solid in the middle, and then this, and then this side is creating an empty in the middle, and then this, and then this. So they're exact opposite patterns of on and off, or however you want to describe it. And so it's a segregation. You're basically segregating the force, separating it, and then shooting it out in a pattern that another magnet can recognize. Another magnet will see that there's a north and a south side in terms of a pattern being created, and they'll act inversely based on the rules of the little bits hitting the paddles. So if you have two paddles of plus, the rule is that the stuff's just going to bounce back and forth if it's plus. And if I have a plus and a minus paddle, you could sort of understand that everything, well, I'll go back to the atom for that example. So inside the atom, the conventional theory is that you have a strong nuclear force that's keeping the protons together. And the much more simple answer is, the protons would be very repulsive, because any energy between them would just keep bouncing back and forth, and if you try to push them in, the ball bounces more times, hits the surface more times. But if you stick an electron in there, then what's happening is all the positive force, right? All the positive force is getting out of here. Any positive force that hits the electron gets deflected, and any negative force that hits the electron, that hits the protons, that gets deflected. So the negative force is leaving, the protons, the positive force is leaving the electron, and therefore no forces can be trapped between any of these objects, and they can get very close to each other. So it's not a strong force that's keeping the protons together. It's a very weak force, in the sense that it's the electron that's allowing all the pressure to escape. So by having the neutron, this object, the neutron, and the proton, you can understand that the two of them end up being a very small, compact object inside the nucleus that will clearly have all the features of being two protons, because this will almost be invisible, this little electron in the middle that's allowing the two protons to get close to each other. So, regular physics thinks that there's a proton, and somehow the proton and proton are getting incredibly close to each other, which, they know there's a whole bunch of force between them, and you can't do that, because obviously they're not recognizing there is no force between them, because it all leaked out through the electron. All right, anyway, okay, so that's basically all you need to understand everything that's going on. Charge is just the fact that the electron force and proton forces act inversely on the objects. So, if an electron exists, it's going to reflect the electron force, and it's going to deflect, the proton force. Now, obviously, it's not destroying the force. It's just changing its direction, so it can't act as effective pressure. It can't keep reflecting between two objects because it escaped. So it just creates the escape valve. All right. Yes. So yeah, all of that answered, all the questions are answered. You know, you can get to every part of the physical events that take place in the real physical universe. The experiments can all be explained using this simple mechanical model. So gravity is, you know, just the fact that if you're going to slow the force down, pushing matter, and you're going to push it in both directions, you know, you're going to push it this way, and you're going to push it this way. Right now, you're bouncing on the surface of the Earth, essentially. You can feel, okay, what part do you feel? Well, you feel the Earth pushing you back, but you can't feel a force that's moving all of your little bits equally. You only feel something when it pushes on you unevenly. So if you were a thing, you can feel it if it pushes just here and puts a dent in you. Gravity is obviously acting on all of your atoms, the little elemental bits. So we're back to gravity. It's working in the smallest universe. It's moving electrons and protons. That's what it's hitting. And it's hitting all of them inside your body. So it's a very even force. So you can't feel it because it doesn't move one part of you more than the other part. You're all being pushed at the same time. So you don't feel gravity. You feel the Earth pushing back because the Earth pushing back is matter pushing back. It's big atoms pushing back. It's not a tiny little rain of force. It's a big giant atoms that are pushing back at you. And so they're denting parts of you and you know, imposing higher pressure in elements, you know. And so that's what you're feeling. But what you're really doing is you are actually being moved this way. Your atoms move that way from gravity. The electrons and protons get moved this way. And then the atoms push back this way, and that's electrons and protons. And they push back equally against that motion. So all of this stuff is just, you're just constantly jiggling. And what happens when you're doing that? Well, you're absorbing force going this way, and you're both absorbing force going that way down. Now, you're also absorbing force sideways, but see, the sideways part doesn't matter because there's not a big giant Earth sideways. So the gravity on one side, the left side of you, is the same as the gravity on the right side of you, so there's no gravity to speak of. There's no wind blowing that way. Where obviously there is a wind change from here, the force going down, because the Earth is busy consuming the energy by moving material objects. By moving electrons and protons, it's using up a fraction of the energy. When a force bit isn't moving the speed of light, if it's taking a longer time to get from point A to B, right? I mean, if it's not getting there at the speed of light, you could argue it's lost momentum, velocity times mass. It's lost energy. So every time an electron is moving, it's consuming energy that was going somewhere else. And it can't get there because it's got to push the boulder of matter first before it can continue its journey, so to speak. And it won't continue the journey. What will happen is the piece of matter you're pushing will hit something moving the opposite direction. You'll actually reflect back home, and the new piece of energy will reflect in the direction you were going. So that's what will actually happen. All right, so I think that's enough detail without getting too detailed, blah, 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 without, you know, just to point out this model has a lot of depth in terms of it has a lot of capacity to explain what we see and why we see it and why it's happening and how it's happening and why the pattern matters and all of that. And it's very simple in terms of it only has these simple elements. The forces are all moving the speed of light. The forces don't interact with the forces. That is, the little bits don't hit the little bits. And if they did, it wouldn't matter because they just exchange their directions. So it's a moot point. And the matter is just a conduit that allows force to cause action in the matter. And when the matter acts, it causes action in the force. So instead of some notion of bent space, well, we'll get to that, where, you know, somehow the space is telling the matter what to do. Here you have a real argument that no, the matter moves because the force pushes it. Because the force pushed it, it's changing what the force field will look like because you change the position of the matter. Changing the position of my hand changes what reflects in your direction. It's just a fact. Okay, your image of this video changes when I move my hand. So the matter changes what the field of force heading for you looks like. And so the matter is just a conduit to allow forces to interact with forces. The forces on one side of me can interact with the forces on the other side of me because the matter will do the math. The matter will say how many bits are over here and how many bits are behind me and decide to move me. And when I move, that will change the balance in the universe. And just understand, every time I do this, I've done the opposite. I've done that in the other direction. So when I do this in that direction, I'm doing the opposite in the other direction. So every action has an opposite reaction, in the sense that every action in one direction, every motion in one direction creates an anti-motion in the other direction. So every push is essentially creating a pull in the opposite direction, in the sense of a lack of energy. So every time I push energy in this direction, I'm taking energy away in the opposite direction. That is, I'm creating expanded space, less density of force in one direction and more density in the other direction. So I'm creating an exactly out of phase copy of whatever happens this way. There's an out of phase copy happening in the opposite direction, which is another perfectly consistent with what is discovered in the process of making photons, is that you often create them in pairs. You're creating in one direction, on off, and you have off on in the other direction. Alright, I'm going to take a little break and be back and such. Alright, seeing that this video is already 40 minutes long, maybe I'll change the agenda. I was going to start getting into some of the arguments. So what I'll do is go through the arguments as presented, what the evidence is for Einstein's bent space, and why that evidence isn't at all significant. When you really analyze it, it's not saying anything really. The Eddington experiment, one of the key ingredients to Einstein's fame, never even been repeated. So I've already made that argument, so I won't make it here. But you can explain time dilation, okay, GPS, all of that stuff can be understood because it all has to do with just atomic clocks and the nature of radioactive decay, for which they have no theory. And so there's very little, and then the precession of Mercury could be understood, that if all I have to do is make the sun's center of gravity process a little, and you could understand that tiny precession, the closer you are to the object, the more that precession will affect you, and the further away, the less it could mean anything. Because the distances are so great that the tiny little precession of the sun's gravity wouldn't mean anything way out here, where it'll mean a lot in here. And that's why Mercury is aberrant to the rest of the planets, is only because it can sense the sun's precession where the other planets can't, because it becomes such a meaningful vibration over such a long distance. So those, there's only 3 or 4 elements for which bent space is based on, and they just exaggerate, the importance. They just do GPS. When GPS is just talking about clocks and how clocks function when you move them, and when you put them in heavy gravity, the simple argument is they're moving more. So again, I've made these arguments about how if you're vibrating something or bouncing something, it's actually moving a lot faster than its actual progress in space, because it has to do all of this extra bouncing. So when you're bouncing in heavy gravity, you're obviously moving a lot faster than you think you are. So if we're spinning on the Earth, but we're bouncing on top of the Earth while we're spinning, you can understand that what our actual electrons are doing is they're moving a lot more velocity than we think, because they're bouncing as they're doing it. Simple analogy, a basketball player, when he's dribbling down the court, the ball is moving at a lot higher velocity than the player is. Alright, And so simple arguments, you know, so we'll go through those, and then we'll go through the kinetic energy argument. So their argument is that the evidence is basically really horrible. The history's terrible. They have some clay experiments, and that's about it. There's no go-to experiment where they show you them pouring 4 times as much gasoline in the tank of the car that's going to go 60 miles an hour versus the one going 30. They say it takes 4 times the energy, but they'll never show you. They won't show you a bullet doing 1,000 times, moving 1,000 times more atoms or electrons and protons than the barrel of the gun. The two reactions, the action and the opposite reaction, are supposed to be equal, yet they say one has 2,000 joules of energy and they say the other only has 2. It doesn't make any sense. It's illogical. So the kinetic energy formula is based on, there's no physical evidence, there's no experiment that shows them collecting any of this extra energy. We have nothing to parallel the example of a 5-ton train going 10 miles an hour and a 10-ton train going 5 miles an hour. Now, the simple thing to do is put a generator on the wheel and say, well, let's see how many light bulbs they can light. Let's prove that one of them has twice as much energy. And they've never done that. And then the photon argument is all based on the double slit experiment substantially, and some related experiments, refraction and reflection experiments that really have to do with understanding how photons interact with matter. Their theory is that single electrons create a photon. There's no way that could possibly happen because the polarization of photons is hundreds, if not thousands, of atoms in size. And you know, the wavelength is many thousands of atoms of difference in separation. How could you even imagine an electron staying in one place to make a photon? You know, it doesn't even make any sense. Something that can hit something else that's standing in one place. It just doesn't make any sense. So clearly photons are things that happen when atoms react with atoms. And so they're produced by a collection of atoms, and they're collected by a collection of atoms as whole photons. The real argument is that photons are broken. Photons are just bullets fired in space, flying through space in a pattern. And the simple truth is you can deflect the individual bullets to different locations, and you can remake the pattern or not remake the pattern. And that's the simple truth. You can take the pattern and reform it back into what it was, or you can change it. And the trick is to go from a longer wavelength pattern means that you have bigger polarization. So to convert a long wavelength pattern into a shorter wavelength pattern, you can't just take two photons of, say, red light, you know, and just superimpose them onto each other. So now you've created a pattern, a photon of blue light by just combining the two red lights at different phase. And now you have this instead of that, and now you have what would be considered blue light. But the trick is that polarization means that you started with red light that had very large polarization, all right, and now you have blue light that has very small polarization. So if you don't fix the polarization, that is, you don't combine the red light and somehow condense it into a narrower polarization, you can't use two reds to create a blue. But it would be easy to make two reds out of one blue because the polarization is already more narrow. And so you can afford, when you just separate this one from this one, you just do this, right? And so now you're creating your red. You already have a narrow polarization, so now you can make it wider, which is a lot more, it's easier to do than to make something narrower. You could just argue that just has to go with a pressure argument. It doesn't take more pressure to make things further apart. So it's easier to do in the universe. So that's more likely to happen than to be able to compress the big polarization of the red light into a blue light. But blue light often creates red lights. It's easy to knock small wavelength items into big wavelength items. Not so easy to take a bunch of big wavelength items and make a small wavelength item. Just one of the little facts. So that's sort of distracting from the point. That's not critical to their argument about their quantum mechanics. So all of the entanglement, all of the superposition, all of the wooiest of the photon adventures are all based on their bizarre interpretation of the two-slit experiment, where they say something breaks into two and interferes with itself and does all of this wacky crap. So the fact is that the physics does present a physical explanation. You can mechanically understand it as just being vectors, just being reconstructing of a pattern, a phase, that the little force bits never interact with each other, they never interfere, nothing gets interfered with. You just break photons, okay, and remake them out of the pieces. And it's a very simple pattern to remake, so no big deal. And you can, that argument works, it explains the phenomenon, and it gives you no good cause to believe in any kind of superposition or Heisenberg, invariability, no infinite spaces, no Huygens infinite waves, none of that stuff is necessary. Alright, so that's enough stated, so maybe that. In the next video, we'll go through the different subjects and I will explain why their evidence is pathetically weak. Even if I wasn't giving you a counter theory that works, theirs doesn't work. It's really bad science, especially in bent space. Well, no, they're all three subjects. It's insanely bad science. The jump to the conclusion, the confidence they have in stuff that they haven't picked at, that they haven't really looked at the evidence. It's dog hair instead of human hair, some kind of bullshit like that. They've mislabeled every evidence envelope, and none of it contains what they say it contains. None of it, when really looked at or inspected, is what they say it is. They never prove light is even bent by gravity, let alone bent twice as much. It's really shameful science. Anyway, and again, it exists in that form because this isn't about science. It's about people being intrinsically motivated poorly, and they really don't have any reverence. They have more reverence for religion than they do the truth and facts. And that's a sad truth. But anyway, don't need to say that either. So anyway, we'll call this a video. So till the next time and such, this has been a DraftScience video presentation. There really won't be any rational challenge to anything said in this video. There just won't be. So, till the next time.